Okay, so we will start with the solution method again once more, and then I will move gradually. Uh, I will actually today you guys are going to solve for me. Okay. Now let me ask who. Okay. Let me ask Vedika Gupta. Vedika, please unmute yourself.
Yes.
Okay. Show me what is the from this equation. How do you calculate this y dot by y? That is capital Y dot by capital Y. Calculate that and tell me what is the result. So you have to give me this. And obviously in the balanced growth path, along the balanced growth path. What is this equals to? And you also have to give me this. That is physical output and per capita output.
So the first one is G plus and the second one is G.
Okay, you're saying for first one is G plus N. Okay. And second one is G. You can solve it, right?
Yeah.
Okay, fine. Now, from here, you have to give me this. Using this equation, in the long run, what is going to be the value of Y by capital K? And you have to give me that. That means what you have to give me. Sorry. Equals to, according to what Sachi Jalote says. So just let me just put it as a constant. So in the long run, it has to be constant. Okay. Equals to what? Remember, along the balanced growth path, this is exactly equals to this. And along the balanced growth path, this is equals to this.
plus G by S.
1 second. Okay. So how do I do it? I will divide both sides by kt first. So this is another way of solution. I will first divide both sides by kt. If I divide both sides of the fundamental equation by kt, I will get this equals to small s yt by kt minus delta. Now what I have to do, along the balanced growth path, my capital K dot divided by capital K is basically my G plus N. So I'll substitute G plus N over here. I will get
Yes, sir, I didn't account for delta. So N plus G plus delta by S.
plus N plus delta
Yes.
plus delta divided by S and you can write it as Y by K. That's your Y by K, and hence in the long run, and hence I can write K by Y equals to S divided by G plus N plus delta. Okay, then we know how to manipulate this equation to get the value of per capita output. So if I manipulate this equation, we have shown yesterday that per capita output can be written as capital AT multiplied by this term K by Y, the bracket, and whole to the power alpha by 1 minus alpha. This is my per capita output, right? Then I also know from this expression that my small kt and small yt can also be written as, in this case, into small kt to the power alpha. Then from here I can calculate my small kt as in the steady state, and also that is basically my steady state capital stock independent of t. So I can write small k equals to So now once I get my per capita capital stock, so um, I can calculate everything now. Per capita output is known for me, wages and everything can be calculated accordingly. So this is another way of solving it. Similarly, if my production function changed to both capital augmenting and labor augmenting, the only thing that will change over here, the rate of growth of physical output will be G divided by 1 minus alpha plus n. So over here in the fundamental equation over here, I have to substitute G divided by 1 minus alpha, and the rest of the solution will follow. Okay, so long run can be calculated. So long run growth in this fashion can be calculated, and the model again can be solved in this fashion. So this is another way of solving it. Okay, so now gradually we are all set to move to the other topic. That means if you can remember the way we have started our economics of growth lecture, the main question that people ask, that why some countries are rich and some countries are poor, that why there is a significant difference in per capita income among different countries. The solo answers that there is a significant difference in savings rate, there is a difference in the population growth rate, there is a difference in the rate of growth of technology, there is a difference between depreciation of capital stock. All those are basically, so from here all those are actually important to explain that why countries are rich and some countries are poor. Rich countries have a higher savings rate, rich countries has a lower population growth rate. Okay, then the question I asked, that why there is a long run growth is different. Again, we have seen the long run growth rate depends on the technology growth and the population growth, G plus N. Since the G plus N is different for different countries, as a result, the long run growth rate is different for different countries. And there is a sustained growth in per capita output. Why? Because the rate of growth of per capita output is basically G. As long as G is positive, I'm going to have a sustained growth in the per capita output. And this is exactly from where people started asking that this G is extremely important. Rate of growth of total factor productivity or rate of growth of technology is important. In the solo model, the rate of growth of technological progress is assumed as completely exogenous. We do not know where it is coming from. And once people realize from the solo model, the rate of growth of per capita output in the long run depends on the rate of growth of technology, people started exploring from where the technology growth is actually coming from. And this is basically our next part of the lecture, that we know that there is a sustained growth of per capita output and it does not fall. This is my Calder fact. Solo explains, the solo model says that the rate of growth of per capita output in the long run is determined completely by the rate of growth of technology. Hence, that the technology growth is sustained, rate of growth of per capita output is also sustained. And this is the explanation of Solo has given to Calder facts. Now, after realizing that, people started asking that from where this rate of growth of technology is coming. How do I model rate of growth of technology? In the Solo model, it is completely exogenous. There is no modeling. We really do not know what from where this rate of growth of technology is coming from. Now people started asking question where it is coming from. And this is basically the next part of our lecture. We are actually we'll follow the same Solo structure. We will not go away from Solo structure, but there are some changes I'm going to introduce in this next model. In the next model, again, there's a household, a constant fraction S of the total output produced in the economy is going to be saved. That is going to be transferred to investment. But now, the production sector has two parts. One is a final good producer, and there is a producer who produce technology. Okay, so this is the basically two things we are going to bring in. To follow the notation, what I will do is basically this. The total labor force in the economy, I am just not writing down, so LT is basically equals to, it is basically has two part. One is LYT plus LAT. So entire labor force now is basically divided between two part. Fraction of the labor force, which is basically my LYT, they're actually producing output. So they are working in a factory where the output is getting produced. And the part of the labor force denoted by LAT, they are actually working to produce technology. And my production function is this. For output production, the production function is this. Same. Uh, Let me just write it down properly. KT to the power alpha is very difficult to manage spot. Take a running note, obviously, huh? This is my production function, how it looks like. Production of the final good. Rest of the assumption of solo model is unchanged. That means that is a household. A constant fraction of this output produced is going to be saved. So the fundamental equation is still this. Savings equals to investment. So now we have two sectors. Final good sector is this. Total labor force is LT. That is a LYT. That is a LAT. LYT is the number of labor that are working in producing output. final output. And LAT is basically labor they are used to produce technology. In the solo model, I do not know where the technology is coming from. Now, technology is basically another input over here. In this production function, technology is another input. It is no longer KT and LYT. So KT is the input, LYT is the input, AT is also an input. Now, is it a constant return to scale production function? Three different inputs. So the production function can be written as kt to the power alpha, at to the power 1 minus alpha, lyt to the power 1 minus alpha. Three inputs. Is it still a constant return to scale production function?
Yes, sir.
Huh? Three inputs. Capital, KT, labor devoted to produce final good output, LYT, and AT, the technology or the total factor productivity is also an input. Three inputs in the production function. Is it still a constant return to scale production function? Who's going to say that? My goodness. Simple microeconomics. A production function is given to you, inputs are given to you. You just only have to check whether the production function is a constant return to scale, increasing return to scale, or decreasing return to scale. Production function is given to you. You have three inputs over here. KT is an input, AT is an input, LYT is also an input. What is the return to scale of this production function? Odrija Odhikari.
Sir, it's a constant return to scale function.
It's a constant return to scale production function. Very good. Priyansha, are you here?
Yes, sir.
What is the return to scale of this production function?
Sir, it's a constant return.
Three inputs. Remember, KT is the input, AT is the input, LYT is the input. Previously, KT is the input and ATLYT is one input. Actually, it was two inputs initially.
Yes, sir.
If I do not have a technology, KT and NT, two inputs. When I introduce the labor augmenting technological progress, KT is the input and the effective labor force, AT&T, is another input. So ultimately it was two inputs. Now I said KT is the input, AT is the input, NT is the input. So there are three inputs in the production function. You have to check whether the production, what is the return to scale of the production function.
Sir, sir, it would be increasing return to scale.
How do you know that?
Sir, if we will put If we'll put lambda kt, lambda at, and lambda lyt, then we'll get lambda to the power 2 minus alpha.
So you are
And
increasing or you are changing kt, at, and lyt by the proportion of lambda, right? Okay, if we do that, suppose I get y prime t. Suppose if I do that, I get capital YT prime, the new output level equals to lambda kt to the power alpha. So let me write down in the bracket. I am actually changing everything in the proportion of lambda. Lambda greater than 0. So where is lambda here? Lambda. Lambda kt to the power alpha. Very good. Then lambda at to the power 1 minus alpha. Where is lambda? Where is lambda? Lambda at to the power 1 minus alpha, and in the bracket lambda lyt to the power 1 minus alpha. If I simplify this expression, what I get?
2 lambda to the power 2 minus alpha into the rest of the production function.
Very good. Lambda to the power 2 minus alpha. Alpha is a fraction. As a result, the power is basically 2 minus alpha is more than 1, and rest of the production function this. Which is equals to lambda to the power 2 minus alpha multiplied by yt. And since lambda is a fraction, the power 2 minus alpha is greater than 1. So it's become a increasing return to scale production function. Now see the difference gradually. Household, they are saving a constant fraction of their income. And that income is translated to investment, just like in the solo model. The difference in the solo model, the production function is no longer constant return to scale. It is an increasing return to scale production function. Just a second, please hold on. So whenever I consider this technological progress 80 as another input to the production function, the production function becomes an increasing return to scale production function. Unlike the solo model, in the solo model it was a constant return to scale production function, irrespective whether the technology term is there or not. But now technology is a choice variable, it's an input, and the production function is increasing return to scale. Very good. Fine. Simple micro question I'm asking before starting the model formally. If we have an increasing return to scale production function from the micro perspective, can I have a perfectly competitive market structure? In the solo model, my market structure was perfectly competitive. What is the implication of that? Constant return to scale technology, perfectly competitive market structure, and we have proven that it basically implies zero profit. Labor and capital, they are paid in terms of according to their marginal product, and that exhaust output. So W into L plus RK equals to marginal productivity of labor into L plus marginal productivity of capital into K equals to Y. This is what we got. But if it is a increasing return to scale production function, what is the implication? Can we have a perfectly competitive market structure here and still we have a zero profit? Perfectly competitive market structure, constant return to scale technology gives zero profit. We have proven that before starting solo model. What did we prove? That if there is a increasing return to scale technology and labor and capital, they're still paid in terms of their marginal productivity, it is still zero profit.
It's negative profit
It is negative profit.
in increasing scale.
If you can remember, we have proven it using uh, that Euler equation. The homogeneous of degree n and n is greater than 1. And suppose labor and capital, they are paid in terms of their marginal product. So the problem, this is basically the problem with the students. They ultimately cannot remember anything. I do not know what is the problem. So this is suppose my equation u equals to a function of x comma y, and suppose it is homogeneous of degree n. What does the what does the Euler equation says? What do you get from the Euler equation? We have done it right at the beginning. If it's a homogeneous of degree n, using Euler equation, what can I write?
Del u del x into dx plus del u del y up into
Del
dy is equal to N into U.
Who's this?
So
On bola.
Priyansha.
I'm writing it down what you have said. 1 second. Let me go to basic math, then I can get del. What you have said is this. Del u del x into dx plus del u del y into dy. Very good. You are saying this is equals to n into u. But according to me, this expression is also of a
No, sir. X into del U del X and Y into del U del Y.
okay. That means you are changing it to x, right?
Yes, sir.
Fine. Very good. Now suppose it's a production function and which is homogeneous of degree n. So let me write down the production function standard. Y equals to some function of k and l. And it is homogeneous of degree n. So according to this Young's equation, sorry, Euler equation, why I'm saying Young's continuously. It is del y del x del y del k into dk into k plus del y del l into l is equals to ny. Suppose I say that labor and capital they're paid in terms of their uh, marginal product. Okay. So what is happening here? Can I maintain? Can I maintain zero profit?
No, sir.
No.
If it
Why?
if we write the profit equation, we'll get profit is like per person y minus MPL into L minus MPK into K, and MPL into L plus MPK into K is NY, and N is greater than 1.
Very good. So ultimately the profit expression, if I manipulate, it basically looks like this, right? Y equals to, in the bracket, 1 minus n, right?
Yes, sir.
Multiplied by,
Y.
and that is basically negative when n greater than 1. And we have also proven it graphically, because increasing return to scale technology means decreasing cost industry. A decreasing cost means average cost is falling down, marginal cost is falling down, and marginal cost is below the average cost. And if you actually set price equals to marginal cost, you are going to get negative profit. So I cannot maintain a perfectly competitive market structure. This is also a difference from the solo model. Once the production function becomes increasing return to scale, that means we have a decreasing cost industry. The market structure also changes accordingly. It cannot be perfectly competitive market structure. what we actually follow over here, a monopolistically competitive market structure. Spare me for the time being. I will come to this particular market structure later. I will explain in detail that how this kind of market structure is solving this kind of problem. That if I impose a monopolistically competitive market structure over here, I do not need to encounter negative profit. I will come to that later. But this is very important over here, that once technology is also another separate input into the production function becomes increasing return to scale. Increasing return to scale production function means a decreasing cost industry. A decreasing cost industry means marginal cost pricing, which is basically the perfectly competitive market structure, is not sustainable because it's going to give me a negative profit. So that means even the market structure has to change from the solo model. The market structure we will follow is a monopolistically competitive market structure. We will come to that, as I said, we'll come to that later. But before, another important thing, do take a running note, huh? That is why I am actually typing it down over here. Just like in the solo model, I am assuming my rate of growth of labor force is n. Same, it is exogenous to me. I am not playing with it right now. Rate of growth of labor force, which is still n to me, and it is exogenously given. So this is it mathematically. Rate of growth of labor force n fraction, exogenously given. I'm not playing with it. I'm only concerned about G right now, the rate of growth of technology, where it is coming from. Somebody is producing technology. Okay, fine. Now, if the total labor force is growing at the rate n, the next thing that I'm going to prove, that means that this LYT, the labor force devoted to produce final output, and the labor force devoted to produce technology A, they're also growing individually at the rate n. Okay, how do I prove that? To prove that, I will take logarithm both sides. If I take logarithm both sides, this equation can be written as, take a running note. Please take a running note. And whenever you have a confusion, let me know. Log of LT equals to log of, now this is what I'm going to do over here. Exponential log of, in the bracket, LYT bracket closed, plus exponential log of, in the bracket, LAT bracket closed, bracket closed. So I think there are a lot of first brackets over here. Let me just, I think this will not be here. Let me just write it down another way. So give it a different kind of bracket. Otherwise, it's getting confusing. So give it a third bracket over here. You write exponential log of in the bracket LYT plus exponential log of in the bracket LAT. I can write down in this fashion. Everybody with me? Sneha,
Yes, sir.
Sagar, Suman.
Yes, sir.
I can write down in this fashion.
Yes.
Okay. Then my job is basically differentiate both right with respect to time. If I do that, left hand side is this. Which is equals to what should be the right hand side? Can anybody tell me? This is fine. Can anybody guide me? How should I do it? You, you are not properly audible. You are not properly audible. Sachi wanted to say, but unfortunately she is not properly audible. Can anybody guide me? How should I do it right now?
Derivative of log x is 1 by x, so we write 1 by the expression that you have written, and then we'll go by chain rule to the derivative of x, and which is e to the power log lyt plus e to the power log log lat. So it will be e to the power log lyt into derivative of log lyt. So it will be pi dot t by yt plus e to the power log lat into l dot at by lat.
Okay. Let me just write it down. If I am writing it wrong, let me know. Because the way you have said, I just couldn't follow anything actually. Let me just write it down first. This is the first expression, right? Am I correct?
Yes, sir.
Then plus the same expression will be in terms of LAT. Am I correct?
Yes, sir.
Okay. So this is basically it. Now this expression can be written as this expression. The numerator will be the steady state value of labor force devoted to produce output. Ly only, the steady state value, Ly. And this expression will be Ly plus La. Remember what I am proving, that if left hand side is growing at the rate n, that is the total labor force is growing at the rate n, then the labor force devoted to produce output Lyt and the labor force devoted to produce technological progress, which is LAT, they are also individually growing at the rate n. Plus now you see Ly divided by Ly plus La, La divided by Ly plus La. If it is n, the sum of these coefficients is basically same, right? 1. The sum of the coefficient is basically 1. So Ly divided by Ly plus La, if you add that with La divided by Ly plus La, is basically 1. So it is basically the total rate of growth of the total labor force is the weighted average of the rate of growth of the labor force devoted to produce output and the labor force devoted to produce technology. The weighted average, the convex combination. Okay, so I can write it down as this is my n. So left hand side is basically my n by assumption. N equals to, if I assume this part is basically omega, Ly divided by Ly plus La is omega, then La divided by Ly plus La is 1 minus omega, and hence I can write it down as plus omega. Where is omega over here? In the bracket, this minus this. Sorry, actually this minus this. In the long run, along the balanced growth path, this labor force devoted to produce technology, that means rate of growth of this labor force devoted to produce technology, La dot by La, and the rate of growth of labor force devoted to produce output, Ly dot by Ly, they are identical. So this cancels out. That automatically proves La dot by La is basically n, which is basically my Ly dot by La. So along the balanced growth path, the term in the bracket is basically 0, because along the balanced growth path, in the long run, balanced growth path means in the long run, rate of growth of labor force devoted to produce technology, which is LAT dot by LAT, minus rate of growth of labor force devoted to produce output, which is LYT dot by LYT, they are identical. So term in the first bracket is basically 0. So it automatically proves my this equals to this equals to n in the long run. So when total labor force is growing at the rate n, in the long run or along the balanced growth path, the labor force, rate of growth of labor force devoted to produce output Y and the rate of growth of labor force devoted to produce technology, they are also growing individually at the rate N. This is the proof. Okay, fine. So omega over here, let me write it down over here, comma, omega. What is omega? Can you tell me? Equals to what is omega? I have assumed Namya, right? Namya Sarnkar. Would you mind unmuting yourself? Namya? Hello?
Yes, sir.
What is the value of omega? I have assumed omega equals to
It's
it's
in the bracket. This one.
I can't hear you. Omega is
Minus Ly upon Ly plus La.
फिर से बोलो. I can't hear you properly.
Ly upon Ly plus La.
Very good. This is omega. This is basically the proof that in the balanced growth path, when the total labor force is growing at the rate N along the balanced growth path, the two labor force devoted to produce output and devoted to produce technology, they are also growing at the rate N.
Sir,
Um,
sir, in the brackets, sir, if we put Ly plus La, it doesn't come to that the upper one equation. I think we have reversed the
no,
two.
I have not reversed. The derivation is perfect. Derivation is perfect.
Sir, you originally wrote L dot y by Ly first, but then you changed it. But
I
according
have
to
not changed
this,
anything.
that
This derivative is fine. There is absolutely no mistake over here. The only thing that I have assumed is basically exponential log of Lyt is basically my Ly at the steady state. Exponential log of Lat is my La at the steady state, which is independent of time, which is constant. Nothing else.
sir, as we open the bracket, we'll get 1 plus omega times L dot A by La.
1 plus omega. If this is omega, this is 1 minus omega.
Yes, sir.
Yes, sir.
But in the n equation, we are getting 1 plus omega La dot by La if you open the brackets. And
Then you
minus,
do. Okay, so if this is omega, this is 1 minus omega. Okay, so that means you are saying Ly dot minus. Okay, fine.
yes, sir, yes, sir.
Ah.
Ly dot minus La dot.
Okay, fine, no problem. Fine, no problem. Then again, nothing
Okay,
changed.
sir, I couldn't understand how in the long run we get the same value. Can you please explain it again?
Along the balanced growth path, everything growing in the same rate. This is exactly what we have proven. That's basically the definition of balanced growth path. In the solo model, in the long run, capital K and capital Y, they are growing at the same rate, G plus N. Small k and small y, they are growing at the same rate, G. That means along the balanced growth path, identical variables that actually grow in the same rate. That is the definition of balanced growth path. So both are labor. Along the balanced growth, both the labor will grow at the same rate. Remember, I'm talking only about the long run or the balanced growth path. The definition of the balanced growth path is basically it is the path along which all the identical variables that are actually growing at the same rate. All capital variables they are growing at the rate g plus n in the solo model along the balanced growth path. All the small variable which is per capita, small letter variable, they're growing at the rate g. That's the definition. Over here, LA is a labor, LY is also a labor. They're identical variable. That means along the balanced growth path, they will grow at the same rate n. If so, then the total labor force is growing at the rate n. LY and LA, they are growing identical rate. They're cancelling out. The term in the first bracket is 0. It basically simply says labor force devoted to produce technology, labor force devoted to produce output, that individually growing at the rate n in the long run or in the balanced growth path. Fine?
But so that would mean that these weights are equal. No.
No, not at all.
Okay,
Omega is a
sorry.
fraction. That's the only thing. It's lying between 0 and 1.
Yes.
Fine. So this assumption is not changing from the solo model, that the labor force is growing at the rate n. But since now I have labor force devoted to output production, labor force devoted to production of technology, we have to determine what is their individual rate of growth in the long run. And we have proven they're also growing at the rate n individually. Fine. Only difference is, and it's a very important difference we will see, that when technology is produced and it is a separate input into the production function is no longer a constant return to scale production function. It becomes an increasing return to scale production function. And since increasing return to scale production function implies a decrease in cost industry, marginal cost pricing is not possible. So perfectly competitive market structure is not tenable. We will use a monopolistically competitive market structure. We will explain that later. But before that, we are going to get the model. Okay. Okay, fine. So we have a lot of time. So now, as I said, the fundamental equation of this model still is this. This is my fundamental equation. Okay, one thing, let me just tell you. Okay, uh, instead of call it omega, let me call it this is very important thing. So put it over here. Uh, I have to change this expression. I am not going to call it omega anymore. How do I do it? Okay, let me just write it down another time. N equals to this term plus, I will call it SR, the fraction of labor force to technological production, the production of technology. This part is unchanged. So I'm not going to call it omega. Okay. So this is not over here. And according to my definition, SR equals to this. So if I divide, it is SR, it is 1 minus SR I think ये थोड़ा सा चेंज होगा ना ये साइन. If I divide SR in this fashion, I think ये equation थोड़ा सा change होगा.
Yes, sir.
I think it will be Ly, right?
Yes, sir. Ly will be changed by L.
And this will be La. Other things will remain unchanged. Again, this will be Ly. So why I'm writing it SR, it has an interpretation. It is basically the fraction of labor devoted to produce technology in the long run. This Ly divided by La is basically your total labor force in the long run. So I can write it down in this fashion. So insert equation equals to the La remains La. And this is basically your L. So this SR is basically the fraction of labor force devoted to produce technology in the long run. That's the interpretation of this expression. The fraction of labor force devoted to produce technology. Fine. Very good. Now, let me go directly to this fundamental equation. Again, as I said, the household is actually saving a constant fraction S of his total income, and it is basically devoted to produce, it is basically invested. Okay, now I am actually going to do the identical manipulation over here. If I do that, first of all, okay, let me first start with this production function, and I'm going to do the same manipulation. So if I divide both sides by yt to the power alpha and do a simple algebraic manipulation, what I can actually write it down is capital YT. I'm just writing down the final expression directly. You guys should check. LYT equals to AT multiplied by, in the bracket, I have something in the numerator, something in the denominator. I have capital KT divided by capital YT whole to the power alpha by 1 minus alpha. Absolutely standard algebraic manipulation, and we have done it before. The same thing we are doing. No problem. Again, the same thing in the balanced growth path. This is basically constant, and that basically says this output is growing at the rate the technological progress. Okay, so this does not have any interpretation. So this term capital YT divided by LYT in the long run has to grow at the rate of technological progress along the balanced growth path in the long run, because in the long run KT by YT is basically a constant. Okay, now the part is we know that this part is actually growing at the rate of technological progress, and we know at the balanced growth path the ly is growing at the rate n. So that means this equation says that in the long run this is what I'm going to get. So let me just copy from here. Identical, no problem. First take this. This part remain absolutely unchanged. Since along the balanced growth path, capital K and capital Y, they are growing at the same rate, and this is basically what I get. Fine, very good, no problem. Then I will substitute that value over here. If I substitute this value over here, I will get the same thing, that this capital K by capital Y identical manipulation. I divide both sides by KT and I realize that G plus N is the rate of growth of capital stock in the long run or in the balanced growth path. Then this is this. And if I substitute that over here, what I will get, this equals to this multiplied by this. So put it in the bracket, insert equation, new equation, this this that is my alpha by 1 minus alpha. Up to this, is it fine? Any question or clarification? Any confusion? We are doing all absolutely identical manipulation. Sachi, it is fine?
Yes, sir.
No problem?
No, sir.
Okay, very good. Only one small step remains. This particular variable in the left hand side is basically does not have any interpretation. So what is our concern variable is basically per capita output. So I will multiply and divide this left hand side equation by LT. So this is exactly what I'm going to do. Capital YT by capital LT multiplied by, sorry, LT by LYT equals to, this term is unchanged. Fine. I can write it down, right? Then the first term YT by LT is basically my per capita output. So I can write small yt equals to this term into, since I'm only concerned about this balance growth, so I will write this actually as LYT YLT and the last step I will write YT equals to capital AT into this term into, in the bracket, this Ly divided by Lt. If it is a long run, then it is basically my 1 minus SR. Again, the term over here is constant. That means per capita output is growing at the rate of technology. So the same thing, the same result in the long run, the same result prevails. Per capita output and per capita capital stock, they are growing at the rate of technological progress because AT is still growing at the rate of technology. So this is also the assumption for here. So I have not written it explicitly somewhere. So let me just write it down over here. It is still growing at the rate of technology, but now we will model technology. So AT and over here AT dot is basically G. We'll go to model that. I still do not know where the G is coming from, but I only know there is some production function of technology because there are some fraction of labor force that devoted to produce technology. So this G is not completely exogenous to me. So I'm giving some amount of labor to some production function that is producing technology, and we are going to model that. In the solo model, this is basically still a solo model, almost still a solo model. Okay, but now the only thing is over here. Why the 1 minus SR is coming from? It basically says if I am going to devote more and more people to technological progress, the less and less people to produce output, it has a negative impact on output. That is why SR is actually coming in the production function with a negative sign. So when the SR is rising, this LYT divided by LT is actually falling down. Basically says when you're actually devoting more and more people to produce technology, that means automatically you are devoting less and less people to produce your final output. It has a negative impact on final output. So this is the part where the SR is coming from. But still, in the long run, anything per capita is going to grow at the rate of technology. And anything physical, that means capital Y obviously is going to grow. I have written over here, it has to grow at the rate of G plus N because K by Y is constant along the balanced growth path, and we have proven along the balanced growth path Ly and La, they're growing at the rate N. So anything physical, they're growing at the rate G plus N. Anything per capita, they're still growing at the rate G. The only thing that I've introduced, my production function is now increasing return to scale. I will have to, it is not still it is not a perfectly competitive market structure. I have to determine that what is the wage rate, what is the rental rate. The simple profit maximization won't do. and we have to model G. Still, I do not know where the G is coming from. But I only think that I have already introduced that a fraction of the labor force is basically I am devoting to produce G. Any question? Priyangsha,
Sir.
any question? Derivation is fine?
Yes, sir, it's fine.
Okay. Obhideep, right? Obhideep. Yeah, Obhideep Khare.
Yes, sir.
Derivation fine? Your understanding? Any question?
Yes, sir.
Still it is fine, right?
Yes, sir.
As I said you that I will discuss that the actual implication of increasing return to scale technology, not perfectly competitive market structure more in detail. Those implications are important to determine my W and R, especially the price of labor and the price of capital. वो हम लोग बाद में करेंगे. But we will do that. But next part is basically our that remains is where does this G coming from? In the solo model is completely exogenously given, just like the rate of growth of labor force. But we are going to model G. We have to have a production function of technology now that will give me G. Okay, and I will substitute that value over here. If I know that what is determining G, then the rate of growth of technology is no longer exogenous. The rate of growth of technology is coming from a production function. It is endogenous. I am deciding how much labor force I am going to devote to produce final output Y, how much labor force I am going to devote to produce my technology A. So this is my endogenous decision. This is the decision I am going to take. So that means if I can model G, that is, there is the production function of producing technology. Labor LA is basically input of that production function. Output is basically some sort of technology. That means the technological growth is no longer exogenous then. I can manipulate my labor force devoted to produce G and I can get different G. So it's an endogenous growth model now. So solo growth model is an exogenous growth model because the rate of growth of technology is completely exogenously given in the solo model. Now we are going to an endogenous growth model where I am determining G endogenously from the model. And that basically we are going to do. And then we will go for a full-blown derivation of W and R also. Because ultimately in the solo model, you see what we have determined. We have to determine a small k marginal productivity of capital. That determines marginal productivity output, marginal productivity of savings and everything. And we also determine the price of labor and price of capital, W and R. In this model also, I have to determine W and R. And to determine W and R, then this particular thing actually will be crucial. Because if I give W and R according to their marginal product, I'm going to get a negative profit. That means I should not give them according to their marginal product. And this monopolistically competitive market structure will come into picture there. Okay. Okay. Any question till now? Please take running note. This is a request. No question? Harsh Makwana. Derivations are fine. You are understanding, no questions, no clarification? Okay, till now we have not done anything new. Whatever we have done in the solo model, the same thing we are doing over here. The only thing, we are not concerned about the short run transition here in this endogenous growth model, and whatever endogenous growth model you take in this growth literature, they only concentrate on long run or along the balanced growth path. In the solo model, you see that we have solved both long run and the short run properties. long run means in the steady state, and we have also analyzed when the model is actually approaching steady state, what is the loop. So we have solved this fundamental equation mathematically. That gives me the time path of capital stock and the way is approaching to steady state. But in the endogenous growth model, uh, they are not concerned about this approach. They are concerned only at the steady state and the long run growth, not at the short run growth and anything. Only economy is a long run. What is the property? You see the same thing you are doing. Economy is the long run. That means capital K dot by capital K is growing at the rate of technology and population growth. I impose that over there. I'm not at all concerned about what is happening in the short run, because now the model is getting complicated. The objective of the model is basically, how do I get a long run technological progress? How do I get a sustainable technological progress? Why it is important? Because we have seen the solo actually has showed me that the, 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 the per capita output growth is sustainable when there is a technology growth is sustainable. When there's a continuous growth in technology, I'm going to get a continuous growth in per capita output in the long run. And that is actually matching with the Caldor fact, because Caldor identified for US for last 1 century, the per capita output is growing at a constant rate and it is not falling down. Solo shown that the per capita output growth is basically in the long run is determined completely by the technological progress. So that means if technological progress is continuous, there'll be a continuous per capita growth and which will match with my data. Now the people we are asking the question, how do we get a continuous technological progress in the long run? What is the mechanism? What is the mechanism that is giving me a continuous technological progress in the long run? This is the question you are trying to answer now. Those questions has already been answered, that why some countries are poor and some countries are rich, why the growth rates are different, why the poor countries are growing at a higher rate compared to the rich countries. Those questions has been answered by the solo model. But solo has shown that one particular Caldor fact, that per capita output is growing at a constant rate over the last 1 century in the US, and its growth rate is not decay, does not decay. Fine. Solo has shown that the per capita output growth in the long run is determined completely by the rate of growth of technology. Fine. That basically implies, if I want to match Caldor fact and solo, it basically implies that if there is a continuous technological progress, then only I'm going to get a continuous growth, sustained growth in per capita output. Fine. Now we are asking, how do we get a continuous rate of growth of technology, a sustained rate of growth of technology, which sustain my per capita rate of growth in the long run? This is I'm going to model now. So we are only concerned about the long run only, not the short run dynamics or the short run transition. So that is why in this derivation till now of this model, I just simply impose all the long run restriction. In the long run or in the balanced growth path, rate of growth of labor devoted to research, rate of growth of labor devoted to output production, they're growing at the same rate. Capital K dot by K, they're growing at the rate of G plus N. Capital Y dot by Y growing at the rate G plus N, long run. Small y dot by Y, small k dot by K growing at the rate of G, long run. Only concerned about the long run. We will only analyze long run properties, because we are going to, objective is basically what are the determinants of G in the long run. That means what determines long run technological progress, because that determines rate of growth of long run per capita output. This is my objective, explaining this y dot by Y in the long run. Fine. Objective clarified. See, I have not spoken to this particular person ever. Kannebona Urvi, right?
Yes, sir.
Yeah. Any question, any clarification, any doubt?
No, sir, not right
No,
now.
derivations are fine. objective is also fine. The solo objective I have just clearly mentioned before solo model. I'm also mentioned clearly what is the objective of this model. Is it clear what I'm trying to achieve?
Yes, sir. Yeah.
Okay, very good. Since now we do not have any question anymore, I'm going to end today's lecture over here. We'll meet again on when Monday is 27th at 3 o'clock. Okay, thank you very much.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.